What's up everyone, this is going to be a quick video on some EDF testing I've been doing recently. I've been wanting to see if printing your own EDFs is feasible, and so everything here is printed from PLA. I guess it all starts with this bus right here. It's just the ESC, the Forest LiPo battery, and FlySky receiver stuffed in the bottom with this 3D printed mount for the EDF just hot glued onto the top. You'll see how I kind of use this to test, well, quote unquote test thrust. It's pretty ghetto. I know people have used like load cells and scales. I've used like thrust arms in the past at school to test thrust, but this is what I have so far. I'm excited to play more around with it, and you'll kind of see how it works. This is the EDF duct slash motor housing. It's pretty simple. It has no intake, it's just a duct here. I think intakes is something I want to be playing around with in the future for sure. And then this is the attachment point to the motor mount on the bus. These are some of the thrust tubes I've been using on my EDF. In theory, thrust tubes with the reduced area at the end, it will speed up the flow and perhaps play around with density as the mass flow is conserved. These two thrust tubes on the left here ended up being way too big. For some reason, I would like to go into this more, but the flow actually reversed through the front of the EDF when I was testing it. And so basically it's just two garbage thrust tubes. They're way too long, or the drop-off angle is way too steep. This thrust tube was decent. It had no flow reversal as far as I could tell. It is very short and not a lot of reduction angle here. Performance-wise, as you can see from the tests, I'm not exactly sure how much it helps. If anything, it probably hindered it. But I made it so that these just friction fit on to the end of the EDF for easy testing. These are the two fans that I printed out for now. One is just a rectangular profile printed like this with 7 blades. Another also has 7 blades with a more airfoil-esque profile. Both weigh about 8 grams. I think this is slightly lighter. I wasn't really controlling too much for the mass of each propeller, but they both have kind of the same design, save the blades. I think the detail on the prints could be a lot better. As you can see, there's like a good amount of warping. The actual structure is fine, I guess, except for the tips of these where I printed out the supports. I think I can definitely come up with better prints for this, but this is so far what I had, and the results are pretty clear. This is the nub that holds the fan down at the end, and so when assembled, you just pop the fan onto the axle, and then you do have a couple mil of space on the edge of the duct, which is obviously not optimal, especially for this is like a 70 millimeter EDF. I would like a lot less space between the duct and the fan. I think it is harder than I thought to create a small space, even just because, you know, screwing the motor into these back brackets here, it's not perfect, and kind of the tensions of each screw kind of move the motor around a little bit, if that makes sense. And so again, I think just manufacturing wise, it's a lot harder to print something with a very small gap than I thought it would be. But that's obviously something I want to continue to iterate. Yeah, and then so I just friction fit the EDF onto the bus, plug the wires in, and it's good to test. I'm using FlySky i6X receiver and transmitter. It's been pretty simple. All I need for now is the throttle. But yeah, let me go into some of the tests real quick. So this is what I made in order to visualize flow for the EDF. It's just staged, kind of cut slips of paper so I can see kind of how far the flow goes across, and then how wide the EDF is dispersing the flow. It's the most ghetto thing you can imagine, but I think it did a good job, especially comparing the thrust tube performance and then the overall performance of the propellers. You can definitely see variation between the thrust tube use and the propeller use. If I were to redesign this, I would make it a lot wider so you can see the dispersion of flow a lot better. I noticed with this EDF, it's going pretty far to the left and right after it's leaving the nozzle. Thrust tubes do account for that, but again, I haven't really settled on a good thrust tube design that actually does what it's supposed to. And so again, if I were to remake this, and I probably will, I'll make it a lot wider Probably add more stages in the middle so I can visualize flow even better. For this white propeller, it actually ended up not producing enough thrust to even get the thrust bus off the ground. I tested it in this on this surface, which is again has a lot less of a friction coefficient, and it ended up moving fine. But you can tell right off the bat that this rectangular bladed fan is overall a lot better, performing a lot better than the white curved profile fan is doing right now. Yeah, and so for tests, that's about it. I think in the future, I want to play around with intake designs, definitely figure out why the flow is reversing with these thrust tubes and keep on iterating thrust tube designs. Iterating everything, but iterating the fan first off. Think I want to experiment with the rectangular blade profile even more. Maybe make it wider, more durable. It actually ended up cracking during my testing, and so to make it more durable, to withstand those cracks, is obviously a necessity for these things. Playing around with curved profiles, I think this is kind of an arbitrary design, and so to be able to play around with that, I think. And then lastly, testing methods. I do want to build something kind of maybe using a kitchen scale to test thrust and get like actual numbers. Different ways to visualize flow. I've seen people use like dry ice, stuff like that. Maybe not the paper method, paper and cardboard. But yeah, that's kind of where I'm at right now. Thank you guys for watching, and I'll keep iterating. I also want to throw servo on this, so stay tuned.